Hi, everyone. Welcome to our live stream series called Meet a Scientist. I'm Anjelica, and I'm here in the Youth BioLab at the Albertson Research Center at St. Boniface Hospital in Winnipeg, Manitoba. We would like to acknowledge that we're located on Treaty 1 territory, the traditional lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene people, and on the homeland of the Métis Nation. In this week's live stream, we are meeting Rebeca Camargo, a master's student working in Dr. Ian Dixon's lab in the Molecular Cardiology Lab from Institute of Cardiovascular Sciences. I have the chat open, so if you have any questions for Rebeca along the way, toss it in the chat. Hi, Rebeca. Thanks for joining us today.
Thanks for having me.
So we're going to start off with a very interesting fact about Rebeca. Before she came to the Albertson Research Center to do her master's, she was actually a physician in Brazil. So my first question is, why did you choose to transition from being a physician to a researcher?
So I've always enjoyed research during university. So the university I was taking, I studied medicine. We had things called academic leagues. And that meant that we were a group of students doing, watching some lectures and doing some internships and following some doctors and also research. So I started learning about research during that time. And the main one I was interested on was cardiology. So that's why I started that. And then to be able to graduate, I had to do a thesis. And my thesis was based on people who are addicted to alcohol and the risk of they had to have a heart attack. So after that, I applied to a scholarship to come to Canada during my university years. And I studied at U of M for a year in 2015. And part of the program was to do an internship. And then I applied to work with Dr. Dalla, that is in the Albertson Institute. And that's why I decided to come back and be a researcher here.
Awesome. And are you enjoying your time about the same, more or less than being a physician in Brazil?
It's very different. Yeah, because I was used to dealing with people all the time. So I had patients, I had around 30 patients per day. And now I'm dealing with doing experiments, which is a completely new universe to me, but it's as interesting too, because then I can know the basis of what I could see in the patients. So that's the difference. Yeah.
Awesome. So we've had a master's student on before, Sonu, and he sort of does the clinical aspect and the lab bench aspect. So you're less clinical and more in the lab doing experiments, figuring out the questions that you have about health.
Yes. So usually I'm working basically with cells and also with proteins and genes. So what we do, we have a transgenic mouse model. And out of that, we are studying the heart and the function. So we are deleting a gene and figuring out what's happening after that. And that's very, very interesting, because then we need to do different experiments so we can analyze that. And we can also, so we have qPCR, we have Western blots. There are different experiments we are preparing every day. And it's very unique because then we can, so this is happening, this is going down, this is going up, and then we can relate to what we see in people after it. So it's the first studies we do, so then we can do the clinical studies, and then we can actually have different improvements in medicine.
Okay, awesome. So in your explanation, you had a couple words that maybe not everybody knows. So one of the first ones is, what is a gene?
So a gene is a sequence in the DNA that will be translated to produce a protein. And then a protein is a macromolecule that will have different functions in our system. So it can be an antibody, it can be an enzyme. So an enzyme will be accelerating a reaction. So this reaction will be happening faster than usual because of this enzyme. In my case, I'm studying a protein called SKI. and it's not related to skiing, the sport. It's named after the lab that discovered this protein, and this protein is actually inhibiting or diminishing the healing process of fibrosis. That's another word that I can explain.
Okay, perfect.
Yes. So then fibrosis is the healing process that happens in our whole body. So for example, but it's a pathological process that when it's the healing process a little more expand. So for example, when you cut your hand, after a few days, you'll see there is a scar tissue there. So it's a different color, it's a different kind of tissue. And the same thing happens in the heart. However, when someone has an injury in the heart or a damage, this healing process keeps going. So some cells called fibroblasts, they'll be producing the substrate, so the base for this scar tissue, and they'll be activated in myofibroblasts. That's the other name for them when they're activated. And then after that, in the heart, they are continuously activated and the scar becomes larger than the area that was damaged. So it's different from when you have a cut in your hand, because the scar is just where you had a cut, but then in the heart is expanding.
Okay, so heart fibrosis is like if you got a cut on your face, that would just heal where your cut is. But if you had, fibrosis, that scar would just keep spreading and spreading and spreading and spreading.
Yes.
So are a lot of people affected by heart fibrosis?
Yes. So what happens when the heart goes through this process of having fibrosis? Most people will have heart failure. So heart failure is a syndrome. So when the heart cannot pump in an effective way to supply enough oxygen and nutrients to the other organs. And many people are affected by it. Actually, millions of people are affected by it in the States, for example. And it's a very high cost disease because then there's no cure for it. There are some drugs that can improve their lifestyle or quality of life, but there are no drugs that can stop this progression. And so that's why we study.
Gotcha. So when you say people get damage to their heart, how does your heart get damaged?
There are several ways, but the most common one is a heart attack. So imagine that all our body is full of arteries and veins, and through them we'll receive blood or send blood to somewhere else. In the heart, the same thing. So there are tiny little arteries that supply blood to the heart. And in some people, they may have, for example, cholesterol plaques that are called atherosclerosis in those tiny little vessels. And then if the vessel is actually completely closed by this plaque, then the heart is not receiving enough blood.
Mm-hmm.
And what happens to a cell that doesn't receive oxygen or nutrient? They may be damaged or die. And that's what happened to the heart. And because the muscle of the heart or myocardium cannot be multiplying the cells as other tissues, these cells that are died need to be replaced by something else. So the space is there. And that's why this scar happens. And it's very important because imagine if we don't have the scar, the heart will have a hole on it. So we need the scar, but we don't need the expansion of the scar to the healthy areas around the area that was damaged.
Right. So heart muscle cells, when they're damaged, they don't come back. They're not like regular cells. They don't keep multiplying and multiplying and multiplying as you're an adult. And then since when you have a heart attack, your heart cells aren't getting any blood, they start to die. And when they die, those fibroblasts come in, patch up that wound, but just keep spreading and spreading and spreading and spreading.
Yes.
Gotcha. We have one question in the chat for you right now. what gene are they deleting in your transgenic mice, and what do you expect to see happen?
So we are deleting this gene related to the protein I mentioned. So this key protein, so this key gene. And what we are seeing now is that deleting this gene, the factors related to fibrosis, so the factors related to this scar formation are also diminished. So they're also reduced. And that's something important because we are seeing that this protein needs to be in a balanced amount in the system to be able to work well. And that's what we are doing now.
Gotcha. And then you were saying when you, in your transgenic mice, you turn the ski gene off.
Yeah.
And then you said that that stops the fibrosis. Is that what you were saying?
Yeah, it's repressing fibrosis too. Yeah.
So does that mean that there's a hole left over if they're not patching it up, or does that just mean that your heart scar isn't spreading?
So now, what I was doing until now is with cells. So it may happen what you are saying, but it depends on when you start doing that. So the first reaction, we always need to have the replacement and to have this scar, but we need to be able to stop that expansion. So maybe using this protein or affecting this gene can be important to you.
Okay. So if you were working on a human model, would you be able to turn off their ski gene?
There are ways we can maybe do it, but the best way would be actually have ski balance. So not having too low or too high, having in a way that it can be able to do its function. Yeah.
Gotcha. And then would that be done through things like medication?
It can be, but then it's way further. Yes.
Gotcha. So your big research goal is seeing what the ski gene does for heart fibrosis.
Yes.
And then for your master's, is that going to be a 2-year project? Are you almost done? Are you in the middle?
I'm on my second year now, probably 2 or 2.5 years, I would say, but we'll see what I keep finding out about it.
Definitely. And then after you're done your master's, what do you think you're going to be doing? Are you going to continue on into research, or are you going to get back into medicine or maybe something else?
I think to me, I'd love to be a clinician researcher.
Yeah.
So being able to work with research, but also with patients, and because I think it's very important for a physician to know the basics. So know the molecular biology, know what's happening with fibroblasts or happening when the scar formation is happening or is the healing process happening, because then we can really understand why this patient is this way. And then we can find better strategies to help this person. So I guess it's a global view, having not just focused on the basic, but not focused just on the patient, because we are a whole, like we are whole beings, and we have the molecular, but we also have the whole organ. And that's why, but we'll see what the future brings.
Awesome. And what has been your favorite part about being a master's student?
I think there are a few things I enjoyed the most. For sure, when having good results, I think that's one thing everyone enjoys. But also being able to troubleshoot. So if something doesn't go right, and the satisfaction of being able to solve that problem, it's very good too. So when we work and find different ways we can work through a problem, it's actually very important. And also the interaction with the other students and knowing what they're doing, what they're studying. So it's very interesting too.
Awesome. So tying back into your medical medicine background and your research background, we had a master's student a couple of weeks ago, and he was doing his master's and he's planning on becoming a physician. And he said throughout his master's, he's acquired a lot of skills that he can bring to the table and be a really good doctor. Do you think, so since you did the opposite, do you think that you've gained a lot of skills that are useful and helpful for you in your master's right
Yes and no, because I didn't have any practice in bench work. So I had to learn all of that from scratch. But at the same time, because I had a global view of a patient or what we're studying, I could be more familiar with what the possibilities after that.
Mhm.
So I could view, okay, so we're studying this, but what can actually affect a person when we finish this study? So I think that's the reverse thinking. So we think, oh yeah, we need to know all the basic so we can know the global. But I had the global first, and then okay, and now what? So I had to just go back and learn all of that too again, or remember some things. So it helped me a lot, but also I had some more hardworking with bench work. Yeah.
Yeah, it's definitely a skill that you just need to keep working towards and working towards. And even being in research for many years, there's so much you just don't know how to do. Like there are so many techniques. You mentioned a couple before. You were saying Western blotting and PCR. Those are just techniques that you can do to measure things.
Yeah.
So there are lots and lots to learn, and I'm sure when you continue on, you'll be learning new bench techniques. So we like to end off our interviews with one big question. Do you have any advice for the young scientists out there today?
Yes. So I think one of the first things everyone would tell someone is study a lot, work hard, find opportunities and accept them, even if it's not your first interest. So sometimes you can be surprised with the things you ended up liking. So that's one thing that's always important. Um, Personal advice, I would say, be courageous. Don't give up. If you have this dream of being a researcher or a physician or even a lawyer, even if someone is watching is not sure about what they are going to do after high school, uh, pursue that. My first dream was to come to Canada when I was 12.
Oh, wow.
Yes, I had to do a project about Canada. And then I came here when I was 20, 24.
Wow.
So it took a long time, well, a long path, but it was worth it. So wait, there are time for everything in your life. And if you think, oh, but I'll do a 3 years major or four, it's one more year, but it's just one more year.
Mm-hmm.
It won't make a difference in the long run. So take your time, do things you like, but also challenge yourself. And always believe you'll be able to finish. Like, even if it's hard, you'll be hard times. Don't worry. It happens to all of us. But
Wow.
yes.
That was very good advice. Very inspirational.
Oh, but I guess it's sometimes important. Sometimes you forget about these little things and the technicals we all learn eventually. So
Exactly. All right. Well, thank you so much, Rebecca, for joining us for our weekly Meet a Scientist interview.
thank you for having me. It was very fun. Oh.
And next week, we're going to have Anne from CCARM, and she's going to talk to Steve about foods. Make sure to subscribe to our YouTube channels for updates. Check out our new website at youthbiolab.ca and follow us on Twitter and Instagram at youthbiolab. Thanks for tuning in, everyone.